Hello, my Calc 2 student. I hope this time is work very well because it's fifth time I'm trying to write this part of your lecture. Today we talk about integration by part. It's 8.2 section and from your book. But before we started, I write three integrals. First, x natural logarithm x dx. Second, well, let's go, it will be x squared plus 3x e exponent x dx. And last one, it will be e exponent x sine x dx. What is interesting in all these three examples? First, we cannot solve. Second, here we have product. Each integral is product to function, but is good function. Some polynomial x or x squared plus 3x, exponential function e exponent x, trigonometrical function sine x, or logarithmic function. And you have information about all these functions. This means you can find derivative, you can find antiderivative, or maybe except natural logarithm x. But once you have product, it's not working. But now we have some special tools to help us what we can do it if we have product to function. But before we prove this formula, go back and remember what is taken derivative from product to function. Differential. You have u dv plus v du. This means u dv will be duv minus v du. It's only linear equation and to write different way. Now I'm taking integral for both sides, and because integral is linear, this means I can do it separately. And now we have formula which help us integrate by part. Looking for first term here, this is integral from differential, fold differential. This means cancel it and you have uv only minus integral v du. This is exactly formula what we need. I think it will be more clear if we're doing example, but now looking here, you have some function and derivative second function. It will be integral from this product, it will be product these two function minus, and here is second integral, it's like switch. You have function when you found derivative before, you have function, and for first function you have differential. Okay. Try doing this example. Use this formula. Now we start example second one. X squared plus 3x x squared plus 3x e exponent x dx. Okay. See what kind of function we have. We have function x squared and we have function e exponent x. What kind of information you have here? X squared plus 3x is some polynomial. When you second degree, because maximum degree is second here, is 2. Okay. If you found derivative, it will be linear, and second derivative, it will be constant. If you try found antiderivative, degree go up. This means third degree, fourth degree, it depends how many antiderivative you take it. What about e exponent x? Take derivative or antiderivative is still e exponent x. Okay, great. This means what I need, my goal, I need my second integral will be more simple than I have integral before. This is integral more simple than I have before. It's happened if one of this function is disappear. It's possible only if you don't have polynomial. Okay, this is help us. This means we have x squared plus 3x. Let's go, it's u. And e exponent x dx. It will be dv. Then 2x plus 3. It will be dx. It will be du. And the exponent x will be only v. Okay, great. This means we are ready now for solving our problem. Okay. Product u and v. This means x squared plus 3x exponent e exponent x minus v du. Okay. 2x plus 3 exponent x dx. What is new integral is better than the integral before. Here you have, before you have polynomial is second degree, here is only linear. This means if you're doing integration by part one more time, looks like we have result. Okay, let's go 2x plus 3. This will be u e exponent x dx. It will be dv. Then as du will be 2dx. And v, it will be e exponent x. Okay, great. What we have? We have x squared plus 3x exponent x minus. We'll be sure I'm right inside parentheses. It's not make mistake with sign. uv. It will be 2x plus 3 exponent x minus v du. This means minus twice e exponent x dx. Bingo! We're almost done. Okay, exponent x. I have x squared plus 3x minus 2x minus 3. And here it will be minus 2a exponent x, but because we have 1 plus 2 and plus c. Continue, little bit simplify. Plus x minus 1 and plus c. We did. Okay. Go backwards. I write 3 different integrals. Okay, so doing some first example. What do you have? X natural logarithm x dx. Well, practically this is easiest way because you don't have any problem what function u and what function v will be here. Because about natural logarithm x, you can find only derivative, but not antiderivative. This means this part will be u. Natural logarithm x will be u. X dx, it will be dv. You can tell me why, but before you doing, you always polynomial part is try. It's after couple of steps, maybe it will be constant. It's great, but here we cannot find antiderivative for natural log x. This means we're doing what we can. Okay, du, it will be dx over x, and v will be x squared over 2. Great. We have uv, this means x squared over 2 ln x, minus v du, this means x squared over 2 dx over x. Here we simplify, and final answer will be x squared over 2 ln x minus x squared over 4 and plus c. Don't forget about c. Some of you forgot. I'm okay with grading, but next time I will be more strong if you forgot about this parameter. Okay. Before we moving for our last example, I think we need to write some fact. I don't know how it's rules or if you have integral where you have polynomial function times function fx dx, whereas equals where fx is one of this function, exponential function, sine function, cosine function, maybe different function. We are looking at continuous and see you can integrate by part, and u function will be p polynomial, and zv it will be fx dx. Okay, and how many times we need? N times until your polynomial function it's not be constant, and final integral is will be table integral. Okay, great. And what about question about our last example, what I write when we start lecture? It will be integral e exponent x sine x dx. Here we have two functions. One of them e exponent x. You take a derivative or antiderivative is still e exponent x. Second, sine x. It's like, it's depend you take a derivative or antiderivative, but it looks like you have sine move to cosine, plus or minus depend what you take it, and cosine move to sine, plus or minus depend what you take it, a derivative or antiderivative. This means it's like you working in the cycle. Okay, try. Maybe this integration by part work at this situation too. Here's, I don't see what function I need doing u or dv. Okay, let's go u it will be sine x, and dv it will be what is left over e to the x dx. This means du is derivative sine is cosine x dx, and v it will be e exponent x. Great. Here we have uv. Okay, great. E exponent x sine x minus v du e exponent x cosine x dx. Great. Looks like we need try doing one more time. But here remember please, you're doing something similar how you did first time. First time u was a sine x, this means here is continue be trigonometrical part, your product, this means it will be cosine x. And dv, it will be exponential part. Okay? This means du, it will be derivative cosine negative sine x dx. And v, it will be exponential function. Okay? Continue. What we have, e exponent x sine x minus, I write parentheses, uv. It will be e exponent x cosine x minus v du, but because we have minus here, it will be plus e exponent x sine x dx. Oh, I'm doing something, I'm solving something, plus c. But I come exactly integral what I have. E exponent x sine x, e exponent x sine x dx. Great. This means if we try build equation, if we put in here it's like I, this means our I equal e exponent x sine x minus e exponent x cosine x minus I plus c. But now it's mean I have linear equation for my integral. Great. It's mean I can found. This mean I equal 1/2 sine x minus cosine x plus c. We did it. Okay. What kind of rule we can write here? Rule is, if you have rule number 2, if you have integral where you have exponential function times fx dx, whereas fx equal sine x or cosine x, cosine x, this means integrate by part 2 times. You come with the linear equation with your integral and you can solve it. Only remember rule. What is u function was as first time, something similar need be second time too. Okay, great. And now we try solving more example. Doing one more possible situation, whereas you have inside integral, it's only one term. For example, I have integral arc sine x dx. Here I have only one function, but here I can use integration by part. But I think it's here we don't have any problem what will be u. U is only one possible function, arc sine x. dv will be dx. du will be 1 over square root 1 minus x square dx, and v it will be x. This means now we're ready for solving this example. uv give me x arc sine x minus v du give me x dx over square root 1 minus x squared. Okay, great. I think a second integral this is integral, we can solve use some substitution. For example, 1 minus x squared I substitute with 2t minus 2x dx give me dt, and this means my result will be x arc sine x minus, this will be plus 1/2 integral dt over square root of t. And counting this integral is no problem. This means here we have x arc sine plus 1/2 t new power is 1/2 over 1/2 cancelled plus c. Don't forget, we need to go back with our old variable. This means we have x arc sine plus square root 1 minus x squared and plus c. We're done. Okay, doing a couple of example. I want to show you more example when you can easier make it your homework. For example, number 24 in your book. Looks a little bit scary because t cosecant t cotangent t dt. If before we're solving example when we have only one term, here it looks like we have 1, 2, 3 function. But these two functions we're doing together and dt together because we're smart and we remember the table derivative, what we have here. U, let's go its polynomial part, t. And dv, it will be all this long cosecant t cotangent t dt. Because it's v here, you can remember derivative, table of derivative, and you can easily see this is derivative with cosecant, only you don't have minus. This means antiderivative will be cosecant, negative cosecant t. Do you here is dt? No problem. No problem if it's work. Okay, right. uv minus t cosecant t minus v du. But because you have minus, this means plus integral cosecant t dt. Integral for cosecant, you have table integral. This means here we have minus t cosecant t minus natural log, absolute value, cosecant t plus cotangent t plus c. We done? Okay, now I'm show you example when it's practically we're solving similar, but what happened if you have some coefficient inside? This means you have product exponential function and trigonometrical. Number 30 is your book. It will be e exponent 4x cosine 2x dx, cosine 2x dx. We need solving twice, and finally we have some linear equation. Okay, great. Let's go u, it will be exponential function, no problem. And trigonometrical part, it will be dv. This means du, it will be 4 e to the 4x dx. And we here, antiderivative for cosine, this will be sine, but because you have coefficient 2 here, this means 1/2 sine 2x. We have, this means 1/2 e to the 4x sine 2x minus v du. 4 times 1/2, it will be 2, and 2 I write out of my integral e to the 4x sine 2x dx. Okay, we need to use integration by part one more time. Here we're doing same like we did before. U exponential function, this means e to the power 4x, and dv, it will be sine 2x dx. Okay, great. This means du will be 4 times e to the 4x dx. What about v? Antiderivative for sine, it will be negative cosine, but we have negative 1/2 cosine 2x. And now we're almost done. 1/2. I'm going to copy this part, sine 2x. Then -2, and here's parentheses. uv give me -1/2 e to the power 4x cosine 2x. Minus v du, but because we have minus here, this means it will be plus 4 times 1/2, it will be 2 integral e to the 4x sine, oops, sorry, so much writing, x cosine 2x dx, close parenthesis. This means now I have exactly integral what I have before. Okay, this means my integral I equal 1/2 e to the 4x sine 2x plus e to the 4x cosine 2x and minus 4 integral I and plus c. Great. Finish please. We have I will be e to the 4x over 5 1/2 sine 2x plus cosine 2x and plus some c. Okay. Well, I think we're doing one more example. For example, number 46. Okay. I have integral from 0 to 4 natural logarithm 4 plus x squared dx. Only one term, no problem. What will be my function u? This means u is natural log 4 plus x squared. Great. And my dv is dx. du, it will be 4 plus x squared. Denominator, numerical is 2x, and then we have dx. V here is only x. Okay, great. Plug in, and we have x natural log 4 plus x squared. Don't forget about border 0 to 4, and minus v dx give me 2x squared dx over 4 plus x squared. Great. What about this part? I think we need little bit continual work. Maybe for not write like function, first term we plug in. If we plug in 4, you have 4 natural log 4 plus 16, this will be 20. Okay. If you plug 0, it will be 0. This means we stopped. Okay. Minus 2. Here we have x squared over 4 plus x squared. And dx there. But now I'm doing this trick we did before too. I'm add 4 and I'm subtract 4. And here is like I'm use this is like for one term, and whereas I'm subtract 4, it's like second term. What does give us? Okay, we have 4 natural logarithm 20 minus 2. Okay, x squared plus 4 over x squared plus 4. It will be 1. And here is second, this will be 4 over 4 plus x squared. Hooray, we have table integrals here. Okay, continue. We have 0 to 4, 0. Oh my god, I forgot about 0 to 4. What we have here? 4 natural logarithm 20 minus twice x minus 4 times arc10 arc10. Here I have x over 2, and this is 2 I need right in the front. And all of this is from 0 to 4. And now if you plug in, you have 4 natural logarithm 20 minus 8 plus 4 arc10. 4 over 2 is will be 2. Sorry, my calculator is not working, but if you write in the quiz or in the test answer some this way, it will be full credit. Okay, this is all what I'm planning to tell you about integration by part. Remember, integration by part not only acknowledges some tools for solving some type of integral, this means more practice and working. Okay, I hope this time is working.